Hi everyone, I'm going to show you guys how to integrate root tan x. So this is going to be a long video, not that long, but yeah. So when starting this question, you'll have to take a substitution of, let's take a substitution of t equals root tan x. Okay, and then we need to differentiate this, right? So dt over dx equals to, so you could write tan x to the power half instead. Let's differentiate of what you have inside. So the differentiation of tan x is sec squared x, and the power comes down half, and the power should be subtracted by 1, right? So your answer would be half sec squared x tan x to the power minus half, right? This is dt over dx, but we need to find dx, right? So you could rewrite this as sec squared x over 2 root tan x. So dt over dx equals to that. Then 2 root tan x over sec squared x dt equals to dx, right? If you go back to your question, so you have the integration of root tan x, and instead of dx, I'm going to write 2 root tan x over sec squared x dot dt. Okay, so now you can take the 2 out, and you have tan x over, because root tan x into root tan x will give you tan x, and sec squared x you can write it as 1 plus tan squared x, right? Dot dt. So what you can do now is, now you had t equals root tan x. Tan x is going to be t squared, and tan squared x is going to be t to the power 4. So now you have to integrate t squared over t to the power 4 plus 1 dot dt, right? And now I'm going to take the 2 back inside. I'm going to write 2t squared over t to the power 4 plus 1 dot dt. Yeah. Okay, now what I'm going to do is, I'm going to write the numerator like this. I'm going to write t squared plus 1 minus 1. This equals to 2t squared, right? Same thing. I just changed it into a different format so that we can break this into 2 fractions. Power 4, t to the power 4 plus 1 dot dt. So now we could take t squared plus 1 over t to the power 4 plus 1 as 1 fraction, plus t squared minus 1 over t to the power 4 plus 1 as another fraction. So this is what you have now, right? So now what I'm going to do is, I'm going to divide the numerator and denominator for both fractions by t squared. So now I'll get 1 plus 1 over t squared over t squared plus 1 over t squared plus 1 minus 1 over t squared over t squared plus 1 over t squared. Okay. You'll see why I'm doing this. I was solving this question before making this video, and I tried many different ways, and this is what I could come up with. So now what you could do is, okay, now just look at the denominator. Look at both the denominators. So t squared plus 1 over t squared. Okay, now I'm trying to write this in a completing square format. So if you tried this, now look. If you try expanding t plus 1 over t in brackets to the power 2, what would this give you? T squared plus 2 into t into 1 over t plus 1 over t squared, right? So it's t squared plus 2 plus 1 over t squared. But we need t squared plus 1 over t squared, right? So to get t squared plus 1 over t squared, all you have to do is just subtract this by 2, right? So meaning t squared plus 1 over t squared is t plus 1 over t squared minus 2. Now, when going further, now let's write down our question. So we have 1 plus 1 over t squared. Hold on, before I go any further, there's something else. So I'm gonna write this in another way. You could also write t squared plus 1 over t squared as, so let's take t minus 1 over t squared. So this would give you t squared minus 2 plus 1 over t squared, right? And to make it equal with this, all you have to do is just add 2. So plus 2. So you could also write t squared plus 1 over t squared equals to t minus 1 over t squared plus 2. So I'm doing it like this. I'm taking the minus version for this and the positive version for this. Because when you take a substitution, you'll see why. Okay? You'll understand. So I'll go back to our question. 1 plus 1 over t squared over t minus 1 over t squared plus 2 dot dt plus integration of 1 minus 1 over t squared over 1 plus, t plus 1 over t squared minus 2 dot dt. So now let's focus on the integration we have on the left side. So for this, you take a substitution of u equals t minus 1 over t. So du over dt equals 1. What's the differentiation of minus 1 over t? Plus 1 over t squared, right? Now you can see, right? Now you can see why I took minus for this and plus for that. So du over 1 plus 1 over t squared equals to dt. So then if you go to your question, 1 plus 1 over t squared over, and instead of t minus 1 over t, I'm going to write u squared plus 2 dot, instead of dt, I'm going to write du over 1 plus 1 over t squared. They cancel off. So now we have the integration of 1 over u squared plus 2 dot du, and the integration of that will give you tan, hold on a minute, no, you can't do it like that. You'll have to take this 2 out first. Let's take it out. So that will give us, so if you take it out, you have half into 1 over u squared over 2 plus 1 dot du, right? And then you can write half into 1 over u over 2, so u over root 2 squared plus 1, right? Yeah. And now let's just focus on this. I know we are taking a whole bunch of substitutions, but don't get confused, alright? Let's take a substitution of w equals u over root 2, so dw over du equals 1 over root 2. Root 2 into dw equals du. So we have half into 1 over 2. So instead of u over root 2, I'm going to write w squared plus 1 dot root 2 dw. So it's root 2 over 2 into the integration of w squared plus 1 dot dw. So what's the integration of that? Tan inverse w. Don't need to put the c for now because we have a whole bunch of integrations to do, right? So root 2 over 2 tan inverse u over root 2, right? This is one part of the answer. Let's leave it like that for now. So your answer would be this plus, I just changed the color so that things won't look jumbled up. So 1 minus 1 over t squared over 1, so t plus 1 over t squared minus 2 dot dt. That is what we have to integrate now. So let's take a substitution of u equals t plus 1 over t. So du over dt equals to 1 minus 1 over t squared, right? So du over 1 minus 1 over t squared equals to dt. So then you have 1 minus 1 over t squared over, instead of writing t plus 1 over t, you can write u squared minus 2 dot du, instead of dt, you write du over 1 minus 1 over t squared. You can cancel these off. And now we have to integrate 1 over u squared minus 2 dot du. So how do you integrate that? You have to use partial fractions, right? You can write 1 over u squared minus 2 as 1 over u minus 2. No, 1 over u minus root 2 into u plus root 2 equals to a over u minus root 2 plus b over u plus root 2. And now you can write 1 equals to a into u plus root 2 and plus b into u minus root. So you could take it when u equals root 2, a equals to 1 over 2 root 2, right? And when u equals to minus root 2, b equals to minus 1 over 2 root 2, right? So you found the values for a and b. Now you just have to integrate 1 over 2 root 2 into u minus root 2 plus, it's not plus, it's minus, because b was minus 1 over 2 root 2, right? So minus 1 over 2 root 2 into u plus root 2 dot du. This is easy. It's ln functions. So your answer is 1 over 2 root 2 ln u minus root 2 minus 1 over 2 root 2 ln u plus root 2. This is for that integration. So you could also write it as 1 over 2 root 2 ln u minus root 2 over u plus root 2, since subtraction means division in logarithmic terms, right? So your final answer would be, in terms of u, would be, what was the answer we get previously? Root 2 over 2 tan inverse u over root 2 plus 1 over 2 root 2 ln u minus root 2 over u plus root 2, right? Now this is in terms of u, but we need in terms of root tan x. Right? If you go to the start of the question, see, the substitution we took was t equals tan x. So we had u equals to, for in this case, I think, no, this is a confusing part. I took both the substitutions as u, right? Just hold on a minute. I'll take this as u dash, okay? Because the substitution I took for this is different, and the substitution for the previous part was different, right? Because it was u equals t minus 1 over t. So I'll make this u dash. So this is u dash. I'm really sorry for taking both the substitutions with the same letter. I hope you guys don't get confused. If you guys get confused and if you guys have any doubts, please drop a comment. I'll help you guys out. I'm sorry for making that mistake. Okay, so it's u dash, right? Here the substitution was u equals t minus 1 over t. Here the substitution was u dash equals t plus 1 over t. Okay, and we had t equals to root tan x. So u equals to root tan x minus 1 over root tan x, and u dash equals to root tan x plus 1 over root tan x. So if you take the common denominator, it would be tan x minus, wait, do you need a common denominator? You could also write your answer like this if you want to, but yeah, let's just take a common denominator. So tan x minus 1 over root tan x is u, and u dash equals to tan x plus 1 over root tan x. So your final answer is root 2 over 2 tan inverse u, which is tan x minus 1 over 2 root tan x plus 1 over 2 root 2 ln u dash, which is tan x plus 1 minus root 2. And the reason I'm not writing the denominator is because you have the same denominator for u dash minus root 2 and u dash plus root 2, right? So they'll just cancel off. So you could just write this tan x plus 1 plus root 2. So this is your final answer. Oh, hold on a minute. I think I'm in this. So it was for tan inverse, it was u over root 2, right? So this has to be root 2. So instead you could just write 2 inside. I by mistake we wrote 2 instead of root 2, that's wrong. So yeah, this is your final answer, right? So yeah, the question is just the integration of root tan x, but the answer is really big. So the question is not that easy, there are specific methods you have to use to solve this question. So if you guys have any doubts, please drop a comment. I'll help you guys out. And if you guys like my teaching, leave a like and subscribe. Have a great day. Thank you so much.